Small World Big Data, and I am really terribly excited today because I get to talk about one of my total favorite things, which is AI and what's going on in the industry today with large language models and multi-agents and RAG and all sorts of cool things. We are going to be talking about the software development process and really how you apply some of this new technology to making exceptionally large gains in maintaining and reducing your what we're going to find out, reducing your technical debt and getting your applications out the door sooner. So hang on. Hi, Frankie. And I call it Frankie. You know, it's Francisco Martin. Frankie, you're with Stride, and Stride is been around for some time. Could you just tell us a little bit about the background of Stride? You know, where you guys got started, how you got into AI, and what sort of your vision and mission are?
Yeah, absolutely. Mike, thank you so much for having me. Super excited to be here. So Stride is actually a 10-year-old services company. We were founded as an extreme programming agile software development shop, serving scaling companies in the New York region, large companies down there. And roughly a year and a half ago, we started to see how large language models were really getting powerful. And we had the vision that they could really change how software is built. And, you know, as craftspeople of software, we decided to explore a little bit what that may look like. And so we started playing with Copilot and all the other tools that were available at the time. And my team came back to me and told me, hey, we are not really finding the type of gains that we think are possible with large language models. So we want to build a product of our own. And I said, all right, let's do it. And, you know, fast forward to today, we've been at it for roughly a year and a half, and we've built this product, Stride Conductor, that uses, you know, multiple LLM agents to tackle some of the most pernicious and painful tech debt that no development team ever wants to fix, and are super excited to be serving our clients like that.
All right, there's a lot to explore here and unpack because some people are still just learning what large language models mean. Other people are concerned with how do I run in production. Some people are going, how do I apply them to my narrow use cases? And you just introduced this concept of multi-agent LLMs, which is going to unlock a lot of power, I think. So let's unwrap that a little bit. So when we're looking at from our perspective as an analyst firm, the appropriate use of AI today in large language models, we look for this application of use case to really narrow this down and say, here's a good place to put this, because we don't just want a chat bot to discuss this. We want to solve something for a business and accelerate something. You specifically were doing this agile programming and narrowed down to this idea of technical debt. Why technical debt versus, you know, new application development or some other facet of this?
Yeah, so I think two main reasons. The first one is that we really started exploring the usage of these large language models for any type of software development, building new features and things like that. And what we found is that for small toy code bases, they work. And that's most of the demos that you see on the internet. But when you actually find a real meaty 15-year-old, 7 million lines of code type of code base, they don't really work. They have a really hard time understanding the context of the whole code base, all the business subject matter expertise. And so we found that by narrowing down into specific use cases, we can actually increase productivity very, very significantly by creating kind of custom configurations of agents. And, you know, when we talk about multiple agents, this is just like a software development team. You know, you have a project manager, you have a tech lead, you have a QA. So you can spin up a large language model powered by whichever model you want, whose goal is to be the project manager. You can have another one whose goal is to be the tech lead, and they can be powered by a different large language model. So when you create these specific team configurations for a specific use case, you can actually really maximize your merge rate, which is effectively the target that we have, which is how many lines of code produced by the large language models are ultimately in production. That is reason number one. Reason number two is that actually very few people like to tackle tech debt. You know, we're talking about mainly three buckets of problems. The first one is static analysis. These are things like linting errors, security vulnerabilities, and so on and so forth. The second one is testing, you know, untested code, adding new unit or functional tests to your code base. And last but not least, replatforming and repatterning, things like upgrading languages, breaking down a monolith into microservices, or translating an old COBOL code base into Java. all of these things are things that developers generally don't like to do. So they're very happy to outsource that to a team of LLMs, as opposed to the kind of new feature development that requires human creativity and is quite exciting for individuals.
I mean, you just mentioned a couple things there. If I've got 17 million lines of code, there's probably no one who really understands it anyway. To keep that, I'm not even sure you could take 17 million lines of code and feed it to a large language, one single large language model, right? Because there's prompt windows and the hallucinations and things that happen when you go that long. So it seems like divide and conquer has to be what has to happen. But I'm and there's so many things to say here, right? And of course, those jobs of testing and replatforming and linting and debugging and even just version upgrading and patching, right? Those become onerous jobs for anybody anyway. So we should hire the robots to do that. But how do you make a multi-agent? I mean, to me, it sounds like you're herding cats sometimes, right? How do you do multi-agent stuff so that they work together well?
So, I mean, a lot of the principles that apply to human collaboration also apply to agent collaboration. And it's no surprise they speak in English to each other. So some of the patterns that we find in human development teams, like pair programming, like test-driven development, they really apply to LLM configurations as well. But every problem, every use case has a different set of agents that is optimized for that. So there's a lot of trial and error, right? Like we find that a certain model performs better for text-based tasks, like a project manager or a product manager. Other models are better at actually developing. Some models are better with some languages. Others are better with others. So by doing this work with our clients in real code bases, we're really fine-tuning what these agent configurations look like, what are they optimized for, so that we can maximize that merge rate that I was talking about before.
I'll make a prediction that at some point in the future, our programming languages will be built to serve AIs who can write those languages better than the human programmers that need the syntax that we use today. That'll be interesting. What are if you have LLMs though doing code development and people have run into issues with that. They've run into several different issues. Maybe you could just run down some of the real dangers if you're just taking something like Copilot or whatever GPT is out there and doing code development with it sort of straight up.
Yeah, I think there are two main things that first come to mind that I've seen happen to my clients when they use other software. One is code quality. Really, it is very difficult for these LLMs to write code that has the same quality of a human developer. So if you don't really have strong regression testing in your code base, you can introduce a lot of defects and have a lot of trouble finding those. So you're going to end up spending more time looking at the LLM pull request, debugging, than actually would have taken you to build it from scratch. The second one is security, privacy, IP. We work with a lot of regulated industries, banking, insurance, capital markets. They cannot really put any code they want into their code base. It needs to be fully traceable. You need to understand exactly what's going on. For a lot of the existing tools, they operate in a black box setting, so that is not really feasible. And second, it's all about security vulnerabilities that could be introduced by the LLMs. It's kind of goes back to the code quality. And finally, IP. There's a lot of debate and trials around IP for text. New York Times sued OpenAI very famously. I think something similar could happen in the software development world. So I think there's a lot of concerns around who owns the code that the LLMs are putting out there if the LLM has been trained with proprietary code.
And so do you have these multiple agent ecosystems or communities looking at each other and keeping each other honest? Is that part of what they do, and then that helps address these problem areas?
Yeah, that's exactly right. I mean, you can have a specific agent. You can spin up an agent whose job is just to look for security vulnerabilities. You can even plug it in to a security vulnerability analyzer like Snyk and have it run that against the code that the other quote teammates are producing. So there are a lot of ways in which you can ensure quality. I think the most important one is to really narrow down the use case and focusing on that, and also taking a bit of a manufacturing approach, right? If you have 10,000 failing tests, you can have the LLMs fix all 10,000 of them. You may want to look at the first 50 in a lot of detail and really have a human review those pull requests. Then after that, maybe you can look at one every 50 or one every 100, just like we do with manufacturing.
Right. So there's definitely different ways to approach how you deal with these to get that efficiency of scale. So you're not being turned into a robot yourself. You're not turned into an AI working and being the slow thorn in that chain, right? So you can really. So let's go back a little bit, saying if I have these communities of agents, which is the thing that you're building IP around here with Stride Conductor, the right communities of agents for these things. You mentioned doing some very specific technical debt tasks. The static analysis, looking for things in problem, testing stuff. Testing. I mean, I've written code. Testing to me is not a natural thing. Writing complete test coverage. So these things help with that. But then this replatforming idea too. It sounds like this may be a hope for a lot of people who've got, I mean, I'm thinking Y2K issues, right? For going back, but any sort of issues going forward on this, how applicable is this to different size code bases and different size customers? Is this just really for the biggest of customers, or where, how available is this going to be eventually?
Yeah, I mean, you can go as small as you want and as big as you want. We're working right now with one of the largest insurance companies in Europe. They have a really
Yeah.
massive procedural COBOL code base from the 80s that we're translating into object-oriented Java. And these clients literally told me, you have changed the ROI equation for us to migrate to a modern language. So far, we've been basically suffering this pain. It was too expensive to solve. It slowed us down very significantly, but now suddenly it's affordable to do it. It's not that the LLMs are fully replacing the humans. There's still a lot of guidance, especially in this use case, that humans need to give the LLMs. The structure of a procedural piece of code is very different than object-oriented, but still accelerate the process in 90 to 100%, which means that suddenly we can get it done in a finite amount of time and really eradicate that pain.
Right, and actually make it doable. I think that's what a lot of people are just aren't
That's right.
fixing their technical debt, and it is something that no one really ever wants to talk about
And very
there.
importantly, Mike, I just want to say one thing, which is also preventing tech debt from creeping out again, right? It's not that you just pay it once and it
Mm.
disappears. The technical debt concept is that you need to constantly be paying it. Otherwise, you're going to accrue so much interest that you're going to go bankrupt. So Conductor can be left behind in your CI/CD pipeline so that every time that someone doesn't write a good test, it can be fixed. Every time that there's a language upgrade, it can be upgraded almost automatically. Every time there's a linting error, it's corrected so that you can free your developers' cognition to do the stuff that they love to do, which is build software and create value for the company.
All right, and I think you hinted at this, just sort of one sort of last question, but how opaque is this process? When you've got a community of LLMs, it might be conceivably hard to figure out what conversations they've even had amongst themselves, much less what's gone inside each of them. So, if I'm looking at it from the outside, can I go back and figure out what they did, or what decisions they made?
That's exactly right. We're taking the approach of a glass box, and that is a really important design principle for us. So you can see the entire log of how the LLMs are talking to each other. They speak in English, sometimes they exchange code, but you can fully trace back what they told each other. They happen to be really nice to each other, so it's very endearing to see them collaborate and inspirational in a way. But joking aside, you can fully trace back what they did, why they did it, and you have it right there for you.
All right, so we can get this audibility and insight as well, and maybe even learn from their conversation and say, "Hey, this is the way we should be doing it from the start." Maybe in that
That's right.
sense.
So sometimes they even warn each other, say, "Hey, this solution is optimal for this amount, this database this big, but if it grows beyond this, there will be scalability issues. You need to think about this performance." So they're actually pretty insightful.
Okay, so again, this idea of using multiple agents really seems to me the way to approach getting better artificial intelligence, more natural kind of intelligence, with some executive functions and some memorization and some other things going on here. Having different specializations come together in concert seems to be a way to tackle complex tasks. Where do you see Stride Conductor going then? I'll just ask you, leave with that. Where do you see this eventually evolving to in a couple of years?
And we're going to continue getting very, very good at solving these use cases. We want to make them as self-service as possible. My goal is to effectively give access to this tool to as many enterprises as I can. I think tech debt is really painful. I've been a developer myself. I really think we can have a tremendous impact in the community by solving this problem. And yeah, the target end state is one in which you get a subscription to Conductor. It lives in your CI/CD. Every time that there is a testing error, linting error, security vulnerability, language upgrade, it gets automatically done for you. You don't have to think about it. You don't have to worry about it.
Wow, as a former product manager, trying to get things out the door, that would just be a miracle of sorts. That would be awesome, right? And we still haven't talked. We still haven't, given the goals. You're like, we're not replacing any of the human engineering or the human fun parts or the human challenging parts or the feature design, the cutting edge stuff. LLMs are what are good because of what they've been trained on, which by definition isn't necessarily the new stuff, right? It's the stuff that should be done right. So I like the application here and the sort of implicit guardrails you put around that. That makes a lot of sense to me. If someone wants to learn a little bit more, Frankie, about where you guys are with Stride and Stride Conductor, and says, "Hey, I've got code. I need to update that. I'd like to get my hands on this." What would you point them at?
Yeah, I would love for them to come to our website. It is Stride, STRID as in David .build, BUILD as in David again. So check us out there. Feel free to send a contact form. I'll be really happy to show you the tool and help you know what I can.
All right, so lots going on there. Thank you so much for explaining this. I know we could probably go for hours just on this multi-agent concept because there's a lot to dive into, but it looks really promising that folks like you and Stride are figuring out how to really apply these LLMs to solving real problems real fast for us, such that by the end of the year, within a year, this could be something that everyone can really just push a button and get done. So really accelerating application development worldwide. Looking forward to it, Frankie. Thank you very much.
That's right. Thank you so much, Mike. I appreciate it.
Take care, guys.